Let's review one last topic before I show you the final problem of the day. In order to do the last problem we want to do today, you must be an expert foiler. But remember, on these FOIL problems, we have the special situation where when you FOIL, the outers and the inners are going to cancel out. Watch. When we multiply the firsts, we get 9x squared. The outers would be 3x. The inners would be negative 3x. When I multiply the lasts, a negative times a positive is a negative. And here's the outers and the inners adding up to 0, so I'll copy the firsts and the lasts only. That happens anytime these numbers and these numbers match with one positive, one negative. When that happens, we don't even have to show this step. We can go directly to the answer. Now this one looks complicated because of the square roots. These actually have a name. They are called a conjugate pair. Conjugate pair meaning these numbers match, but one positive, one negative. So we know when we FOIL these that the outers and the inners are going to add up to 0. Let's try it. We'll multiply the firsts. Square root 49. When I multiply the outers, that's negative 2 square root 7. When I multiply the inners, that's positive 2 square root 7. And multiply the lasts, that's a positive times a negative is a negative. Let's simplify. Negatives 2 radical 7 and positive 2 radical 7, those add up to 0. The square root of 49 is 7. Copy the minus 4, and 7 minus 4 is 3. That's simplified quite a bit. Now here's what the last problem of the day looks like. Our job is to rationalize the denominator. It's considered bad form to have a square root in the bottom of a fraction. But just multiplying top and bottom by the square root of 5 won't do it for this problem. Instead, we'll multiply top and bottom, but we'll multiply top and bottom by the conjugate of the bottom. Here's how it'll look. If this one is square root 5 minus 4, I'll use square root 5 plus 4. They're conjugate pairs when one is minus and one is plus. Whatever I do in the bottom, I must match in the top. And then I multiply. Let's do the bottom first. And since the bottom are a conjugate pair, I'll use FOIL, but I'm going to remember that the outers and the inners are just going to cancel out and add up to 0. Here we go. Multiply the firsts. Square root 5 times square root 5 is square root 25. When I multiply the outers, that's positive 4 radical 5. The inners, that's negative 4 radical 5. Those are going to add up to 0. Then multiply the lasts. That's a negative 4 times a positive 4 is a negative 16. Let's finish the bottom. The square root of 25 is 5. And 5 minus 16 is negative 11. For the top, we'll take this 3 and we'll distribute once, we'll distribute twice. Here's 3 times the square root of 5. And 3 times 4 is 12. There's nothing to simplify in the top, so we'll copy. And we'll copy. Now that final answer doesn't look any simpler than the original problem, except there's no square root in the bottom, and that was our goal. This fraction has the same value as this fraction, but the bottom has been rationalized. Let's try one more example. Here I have another fraction, square root in the bottom, not supposed to have the square root in the bottom of a fraction. We'll have to rationalize the denominator. Let's put this in parentheses. And we'll multiply top and bottom by the same value so that I don't change the value of the fraction. And I'll multiply top and bottom by the conjugate of the denominator. So if this says the square root of x plus 2, I'll use the square root of x minus 2. I want to make sure that that sign and that sign are opposites. Whatever I use in the bottom, I must use exactly the same thing in the top. Let's do the bottom first. We're going to use FOIL, but since they are conjugate pairs, 1 minus, 1 plus, I know that the outers and the inners will add up to 0 and cancel out, so I won't bother writing them down. Let's multiply the firsts. The square root of x times the square root of x is the square root of x squared. The outers would be negative 2 square root x. The inners would be positive 2 square root x. Those add up to 0. The lasts are positive 2 times negative 2 is negative 4. Let's finish the bottom. The square root and the square cancel each other out. That finishes the bottom. In the top, we'll take this negative 5 and distribute. Negative 5 times the square root of x looks like this. Negative 5 times negative 2 is a positive 10. These are not like terms, so I can't combine them. And nothing reduces. So we'll leave our answer just like this. All right, your turn. Go work a few problems. I've enjoyed working with you today. I'll be looking forward to seeing you again next week. Bye.